sent planet hunters Jeff Marcy and Paul Butler back to analyze the data they'd been collecting for the past decade. Their team had been looking for the expected long-term wobbles caused by a giant planet.
We ourselves suddenly realized we should analyze our data in a slightly different way, look for the shorter period planets, not just planets that take a long time to go around their star, and that led us to discover within existing data all of these planets that had been buried there for years. I remember the day like it was yesterday, December 30th, 1995. And at 8 a.m. the phone rings. I pick it up. It's Paul Butler, my ace collaborator for 20 years now. And Paul just said, "Jeff, come over here." So, of course, I immediately got in my car. I drove right to this very office right here where I'm sitting now in Campbell Hall at UC Berkeley. And he showed me his computer screen. And there on that screen was the unmistakable graph of the wobble of the star 70 Virginis, going up and down the star, wobbling to and fro, exactly as we had imagined a planet signature would look in our data. So that was the moment, with both of our eyes open this wide, that we knew we had discovered our first planet, the second planet ever discovered.
70 Virginis b is 59 light-years from Earth in the constellation Virgo. With a mass at least 7 times larger than Jupiter, this world immediately claimed the title as the planetary heavyweight of the known universe.
Here, right before our eyes, essentially, is a planet 7, maybe 10 times bigger than our own Jupiter, telling us immediately that, yes, nature does make planets even bigger than the largest ones we have here in the solar system.
Rather than a hot Jupiter, this planet was the first of a new class of alien worlds called eccentric giants, because of their eccentric or elongated orbits. 70 Virginis b swings out as far as 63 million miles from its star and passes as close as 27 million miles.
The frightening aspect of the planet around 70 Virginis is that we all grew up in kindergarten learning that planets go around the sun in nearly circular orbits. So what in the world is a planet doing going around its star in one of these elongated, wacky orbits?
Already, the first 2 planets discovered around alien suns were challenging our view of how planets should behave. Further discoveries over the next decade would show that eccentric orbits are common in the universe, while the circular orbits of our solar system seem to be rare.
It's embarrassing, frankly, when you think about how we humans imagined planets would orbit other stars, how common they would be, what properties they would have. Guess what? We imagined that those planets would look just like the planets that orbit our sun. Extraordinarily nearsighted in retrospect, and for a scientist I find it embarrassing that I was a party to this. But in fact what we've learned is that planets around other stars are remarkably different from the representatives we have around our sun.
The planet hunting revolution that began in the 1990s has also obliterated any notion that planets are rare in the universe. With an ever-growing catalog of alien planets, astronomers are now trying to learn all they can about the more than 200 worlds they've already discovered. The Doppler technique used by Jeff Marcy and other astronomers tells them the mass of the planet they found, but it doesn't tell them the size. To figure out just how big an alien planet is requires a bit of good luck. The orbit of the planet has to be aligned in such a way that from Earth we can see it pass directly in front of its star. This is called transiting. By measuring how much the starlight dims during this transit, astronomers can actually determine the size of the planet. In the fall of 2007, astronomers were watching when a hot Jupiter called Trace 4 transited its star. The planet was about the same mass as Jupiter, and therefore should have been roughly the same size. But astronomers were in for a surprise. Trace 4 turned out to be almost twice as big as Jupiter. It was, in fact, the largest planet ever discovered, sort of a Jupiter on steroids.
Some of these extrasolar planets are really fluffy. They're really expanded in size. And we think that the reason why that's happening is because they have an internal source of heat, which is raising the pressure inside the planet and causing it to expand. That's very similar to a steam boiler on a steam train. In a steam boiler, you have water which is being heated by a heat source. That water is turning to steam, the pressure is increasing, and that's causing the piston of the boiler to move out, to expand. If you didn't have the gas's ability to expand, the planets wouldn't inflate, steam trains wouldn't work, we wouldn't be climbing up this mountain.
While internal heating is the likely cause of the so-called fluffy Jupiters, something much stranger is happening on this alien world. In the field of extrasolar planets, it seems each new discovery creates a brand new world of scientific intrigue. At the University of Arizona, planetary scientist Adam Showman ponders the weather on other planets. Recently, Showman helped generate the first ever forecast for a planet beyond our solar system. And what he found was weather truly befitting an alien world.
We think that the winds are probably about 6,000 miles per hour, possibly even more. This is huge compared to the wind speed on any planet in our solar system.
This is HD 189733b. It's a hot Jupiter, more than 60 light-years from Earth, that races around its sun-like star in a little over 2 days, at a distance of only 3 million miles. How is it possible to divine the weather on a planet 370 trillion miles away? First, you have to take the planet's temperature. Scientists knew that since the planet orbits so close to its star, it would be tidally locked, a gravitational effect that would cause it to show the same face to the star at all times. One side would always be bathed in the burning hot light of the alien sun, while the other would be cloaked in perpetual darkness.
If there was no wind on these planets, then that would mean that the day side would then be very, very hot, and the night side would be very, very cold.
In the spring of 2007, scientists used the Spitzer Space Telescope, which sees in infrared wavelengths associated with heat, to generate a crude map of the temperature on both the day and night side of the planet. You are actually looking at the first map of any kind made of an alien world. What the map shows is that the day side of the planet is roasting at an otherworldly 1,500 degrees Fahrenheit. No surprise, given how close the planet orbits to its star. What was surprising was how hot the night side of the planet turned out to be. Despite being in total darkness, it swelters at around 1,000 degrees. Clearly, something was distributing heat throughout the planet's atmosphere, carrying thermal